Hello students, in this session we will see the PYQs of motion in a straight line, right? So we have completed all the theory part. So the stuff that we have seen in the theory were like the difference between distance, displacement, velocity, speed, and we did see acceleration, okay? We saw all those things and the graph related to velocity, displacement, and then the acceleration, okay? So we should be clear with all those things that we have seen. Then we saw like kinematic equation, fine? So kinematic equation is something that you should have learned in your lower grades. Anyway, we did see the concepts behind kinematic equation, okay? So we completed that part. Then with relative velocity we completed all those theory parts, okay? So you should be clear with all those concepts that we have studied. So with those concepts I'll be able to solve the sums, okay? We'll be able to do all those PYQs, right? So there are around like 33 PYQs, 34 PYQs in this chapter. So in every session, so I'll take around like 3 sessions to complete this PYQ, okay? So in every session we will complete around like 10 to 11 sums, fine? So with that, all those PYQs until 2023 will get completed, right? So let's jump into the first sum, which is a particle covers half of its total distance with a speed of v1, right? So there is a particle which is covering half of its distance with the speed v1, right? And the rest half of the distance with speed v2, which means the particle is having like two velocities to cover that particular distance d, okay? Fine. What should I actually find is its average speed during the complete journey is, right? So now I'll have to find the average velocity, which means if the particle has to cover that particular distance in the same time, then what should be the constant velocity? So that's going to be my average velocity. In the question that they have given, you have like two different velocity, but in the thing that they're asking us to find is like average velocity, which means I will have to have same velocity. With that same velocity I should be able to complete the entire distance, okay, with that same velocity itself. Then that velocity is called as average velocity, right? So while doing the sum you'll get to know a little bit clear. So first let's interpret the first statement as diagram, okay? So we'll draw the diagram for the first statement, got it? So for the first statement you'll have something like this. There is a particle, okay, so that is about to cover a distance d, okay? So in that situation what actually happens is it is going to cover a distance of d by 2, fine. So it is going to cover a distance of d by 2 with an velocity v1, fine. So for the next instant, then for the second half it is going to cover a distance of d by 2 and the velocity will be like v2, right? So it is having like two different velocity to cover a distance capital D. In that situation what I'm about to find here is I'll have to find the average speed during the complete journey. So I'll have to find the average speed, which means if the car starts from a point and then it ends at certain point, in that situation what should be the same velocity with which it should travel, so that it will be able to cover that distance in the same time as in the case of two different velocity, okay? That is what I need to find. Now let's consider the first part, then I'll do the second part, then we can combine both those parts, okay? So in the first part the velocity will be like v1, which is equal to, obviously the velocity will be like displacement divided by time, okay? So distance or displacement, it doesn't matter in this sum. Therefore we'll have like d by 2 displacement divided by the time, right? So time isn't something that is given, okay, but the thing that is known as, in both those situations time has to be constant, right? So here for the first half I'll consider the time to be like t1, okay? So this object is actually going to travel a distance d by 2 with velocity v1 and the time taken here is like t1, okay? Then what will be the case in the case of second section? So for the second part you'll have like v2, you'll have the same distance d by 2 and the time taken there will be like t2. So depending on the velocity v, the time will differ, right? So now what I'm about to find is I'll have to find an average velocity, constant velocity, such that it covers that complete distance with the same time, right? So that same time is actually the sum of t1 plus t2, right? So in this situation these two times could be different, but the thing is that while finding the average velocity it should actually be the sum of these two time, right? So that is how average actually comes into picture, right? So you have like time which is equal to time, net time should be equal to t1 plus t2, right? Now I am about to find the average velocity. So if I get the average velocity, it will look something like this. V average will be equal to total distance, okay? You should cover the total distance with that particular constant velocity and the time will be like equal to total time, right? So it should be like t1 plus t2. Anyway, total distance divided by t, will give me the V average. Fine. So in the numerator, there is nothing much to change. Okay. So we'll have like D, that's going to be the same thing. So instead of T, I'll be able to substitute T1 plus T2, right? Okay. So with respect to that T1 plus T2, what I'll be able to do is I'll be able to rearrange this equation, right? So if you look at the options, I'll have to make a combination such that you have like V1 and V2. So in order to get V1 and V2, I'll have to get rid of this time t. So if I have to get rid of this time t, I'll be able to replace it with T1 and then T2. Then instead of this T1, I'll be able to write it as D by 2 V1, right? Okay, I'll do it, I'll be able to get it. Okay, so the next step that I'm about to do here is D divided by T1 plus T2. Total time will be equal to summation of those individual times, right? So instead of this T1, now I will rearrange it something like this, D by 2 V1, and then instead of T2, I'll be able to rearrange it with D by 2 V2. Okay, so let's do it. So the next step is D divided by, instead of time T1, you'll have like D by 2 V1, and then plus you will have something like this, D by 2 V2. Okay, fine. So D will get cancelled out, right? So if I factor out D, so all those D's will get cancelled out. Okay, so then what I am about to do is I'll be able to do the cross multiplication thing, right? So when I do the cross multiplication, you'll have like 2, let's do the cross multiplication. So I'll have 1 divided by 2 V2 plus 2 V1 divided by, so denominator I'll have to multiply it, so I'll have like 4 V1 V2. Okay, so if I am about to factor out those two, then I'll have like 2 will get cancelled out, and for that 4 we'll have like 2, right? So now I have got the final relation. Got it? If I just flip it, I'll get the answer. Therefore the answer here is obviously, so the answer here will be like 2v1 v2 divided by 2v1 v2 divided by v1 plus v2. So that's going to be my answer, right? Okay, let's cross match it with the options. You will have 2v1 v2 divided by v1 plus v2. Therefore the answer here is like option 3, right? It should be easy, right? You shouldn't have any doubt into it. So here what I'm finding is actually the average velocity. When I'm about to get the average velocity, what I should do is actually, you consider the total distance and then divide it by the time, right? That common time is something that I will be able to get from all those individual times, right? So if I substitute that one into that total time, I'll be able to get the average velocity, right? There shouldn't be any doubt in this sum. Let's move to the next one. This sum is similar to the previous sum that we have seen. So both those things are like same pattern sum. Let's see what it is. A car moves from X to Y. Okay, so there is a car which is moving from X to the point Y with a uniform speed Vu. So it is moving with an uniform speed Vu, and then it returns to the X. Then it actually returns back to the X with a uniform speed Vd. So there are like two speeds given here. Fine. So what I need to find is like the average speed for the round trip is. So what is the average speed? That's what I need to find. So let's do a picture to it. So you have something like this. There is an car that starts from the point X and then it goes to the point Y. Okay, so it starts with X and then it ends in Y. Got it? So this is actually a round trip, which means it goes forward and then it also comes back. Okay, so for that forward motion, which means from X to Y, it goes with a velocity of Vu. Okay, so it goes with a velocity of Vu and then it returns back with an uniform speed of Vd. Right, what I'm supposed to find here is the average speed, right? So they have given us to find the average speed. If it was like average velocity, then it should actually be 0, because the displacement here for that round trip will be like 0. Therefore if they have given you average velocity in this case, then it should be like 0. But what they have given over there is like average speed, right? So for that average speed, speed actually means path length divided by the time, or distance divided by the time. So when you consider the distance, you shouldn't take the directions, right? So you should just consider the entire history, right? Whatever the distance that I have traveled, I should add up all those things. That is how I'll end up getting distance. Okay, if in the question they have given you like average velocity, then you could straight away match it with 0, right? Look at the options, 0 would be your answer, right? So in this situation they have given us the average speed, right? Therefore I'll have to do the sum the way I did the previous sum. Okay, so both those things will give you the same answer. Let's do it. Okay, so in the first initial case, let's consider the distance to be like d. Okay, So the distance in this situation is d. Fine. So let's solve it. For the forward motion, you will have something like this Vu, which is equal to d divided by the time taken. Let's consider it to be like t1. Okay. And then for the second case, when you're coming back, you'll have Vd, which is equal to d divided by t2. Right. The same procedure, right? Whatever we have done in the previous sum, we will do the same thing here. You'll end up getting the same answer. Okay. So now what I'm supposed to find is like V average, right? So V average is actually the total distance that is traveled divided by the time, right? So here it is distance, not the displacement. Therefore, all the length that I have covered has to be added, right? So the forward length will be like d. Same way I came backwards, that too will be like d. Therefore, the total length will actually be 2d. Okay. So the total distance is like 2d divided by the time. So time should be the summation of t1 plus t2, right? The same logic. Therefore, I'm about to add those two things. If I'm about to add those two things, let me substitute it straight away. You will have d divided by vu, right? So we'll have d divided by vu, and then plus you will have something like this d divided by vd. Okay. So now let's cancel it out. Just flip it, you'll get the answer. 2, 2, 2, everything will get cancelled out. Just do the cross multiplication and flip it. Okay. If I do the cross multiplication, you will have 2 divided by Vd plus Vu divided by Vu Vd. Okay. So in the last sum, what I did is I took the first half distance as d by 2 and the second half as d by 2. In this situation, I took the first distance as d and the reverse distance as d. Okay. So in that both those things are like the same logic, but the thing is there I took it as like half. Therefore, I was supposed to solve something extra with the case of denominator. Still, I ended up getting the same answer, right? So here also I'll have the same answer, which is like 2 Vu Vd divided by Vd plus Vu. Okay. The answer here is option 4. Right. So this is also similar to that of the previous sum that we have seen. So you shouldn't have any doubt on this question. Let's move to the next one. Next sum is a car runs at a constant speed on a circular track of radius 100 meter. Got it? So car is moving on a circular path and then the radius of that circular path is actually 100 meter. That's what they have given. The speed is also constant. You have like constant speed. Okay. Taking 62.8 seconds for each circular lap, which means for every circular lap it takes around 62.8 seconds to complete that one particular lap. Okay. The average velocity and average speed for each circular lap respectively is. So what I'm supposed to find here is velocity and then the speed, average velocity and then the average speed. Average velocity is something that is straight away not, because for every circular lap the car comes back to the same initial position, right? So here the average velocity, obviously displacement is going to be like 0, therefore average velocity should be like 0. That is straight away. Got it? In order to get the average speed, I need to know the distance or path length. So to get the distance or path length, this is nothing but the circumference of the circle, right? Therefore, they have given you the radius. To get the distance, what I should do is I'll have to put 2 pi r divided by the time. Time is something that they've given in the question, which is like 62.8 seconds. Okay. So here for the answer, we'll be able to get it straight away. Average velocity is obviously 0. Therefore, the first one has to be 0. Option 1 couldn't be the answer. Option 2 or option 3 should be the answer, right? So in this situation, option 2 cannot be the answer because the second one is also 0, right? That is not possible. We know that you will have some average speed into it, right? Because you have distance, therefore obviously you will have average speed, right? Therefore option 2 couldn't be also answer. Therefore the answer should be like option 3, right? We can find out the answer straight away. Anyway, we'll do the solving, right? So answer 3 should be the answer. Let's find the average speed. It should be equal to 10 meter per second. Okay, let's verify it. So to get the average speed, V average will be like equal to distance divided by time. Distance will be like 2 pi r divided by the time, right? So time is something that they've given us straight away, which is like 62.8. Let me do the math solving. So here you'll have like 2 into 3.14. So it will cancel out straight away into r. What is the r here? It's like 100 meters divided by the time. Time will be like 62.8. Okay. So it is pretty clear. 2 into 3.14 will be like 6.28, right? So this thing and this thing will be able to cancel it out straight away. This is like 6.28, this is like 62.8, right? So in the denominator you'll have like 10, right? So when you do the cancelling stuff, that will be like 1, so this will be like 10, right? 6.28 into 10 will be like 62.8. Therefore when you do the cancelling stuff, you'll have 10 in the denominator, right? And then 0 zeros will get cancelled. Fine, then you're just left with 10 meter per second. So that's the answer, right? So the answer here is like average speed will be like 10 meter per second. So as I've already told you, we have marked the answer straight away because you will not have any average velocity into it, but you should have average speed, right? So the only option matches that logic is actually option 3. Therefore 3 should be the answer, right? You shouldn't have doubt in this part. Let's move on to the next one. Next question is based on differentiation. Let's read the question. Here you have two cars P and Q starting from a point at the same time in a straight line. Okay, so it starts from the same point and that too in a straight line. Okay, and their position are represented by x. They have given you some equation for the car P, which is like xp. Okay, and then for the car q they have given you xq related by some equation. Got it? So the position of the car is actually related by two different equations. That's what they've given over there. What I'm supposed to find is at what time do the cars have the same velocity. So what I need to find is when will the car have the same velocity. That's what I need to find. So the hint that they have given is vp should be equal to vq. The velocity of the car P and the velocity of the car Q should be same. Then what will be the time? That's what I need to find, right? So first I need to get Vp and then the Vq, right? So in order to get the Vp, they have given us the displacement in terms of some equation. Got it? So if I need to get Vp, then what should I do? I'll have to differentiate the displacement with respect to time, right? If I do the differentiation, I'll get the velocity of the car P, right? So these are logics that we have already seen in the theory part itself. Therefore you should know straight away. Okay, so now I'm about to get the Vp. So Vp will be like df xp divided by dt, differentiation of x displacement with respect to the time. Okay, right? If I do the differentiation, what will I get? So let's put it this way. For the first one, d divided by dt, instead of xp I'll substitute at plus bt square, right? So when you have two terms either added or subtracted, I'll consider each to be like individual term. Okay, so first I'll differentiate the first element, okay, and then I'll differentiate the second part, right? Or else you'll do the inner multiplication. You'll have like dat divided by dt plus d of bt square divided by dt. Okay, so both those things fall into the same logic, right? So first do the differentiation of the first part and then do the differentiation of the second part. Okay, so that's what we are going to do now. So if I do the differentiation, I'll have a plus 2bt. Okay, now I have found out velocity of the p, car p. Okay, it is done. Next what I'm about to find is like velocity of the car q. That's what I need to find, right? So vq will be equal to dxq divided by dt, right? So here xq is actually ft minus t square, right? I'll do it straight away. It's like ft minus t square. Then you'll have, if I differentiate the first part, I'll have like f minus 2t, right? You should be clear with the differentiation, right? That's why I'm going it straight away. You should understand this one, right? So you'll have like f minus 2t, right? Now I have found out vp and then vq. Now I'm ready to equate those two things. So when I equate it, you'll get f minus 2t, which is equal to a plus 2bt, right? Now if I do just the rearrangement thing, I'll be able to get the time t, right? So first I'll put the term which has time into it on the left hand side. Rest all of the terms will be on the right hand side. Okay, so let's move it. So if I do the solving, you'll get, so if I move it, you'll have something like this, right? You'll have like 2bt, okay, and then plus 2t, which is 2bt plus 2t. So you'll have like f minus a. Now let me factor out t as it is common in both the term. Therefore you'll have like, let's factor out t or 2t. Okay, 2t. So you'll have something like this, b plus 1, which is equal to f minus a. Now if I do the rearrangement, I'll get the answer straight away. So time t will be equal to f minus a divided by 2 into b plus 1. Got it? So the answer here is like f minus a divided by 2 into 1 plus b or b plus 1. Therefore, the answer here is option 4. Right? You should get the sum, right? There shouldn't be any doubt in the sum. The thing that we have done here is we just have done the differentiation with respect to the displacement, and then I got the velocity for the car, for the two different cars. Okay, then I equated the velocity because they have given in the question clearly what should be the time when the velocities are same. So that's the hint. So I'll be able to equate the velocities of the two cars, and then I'll be able to get the time out of it, right? So I just cross matched it, and option 4 was my answer, right? You should be clear with this sum. Let's move to the next one. Next sum is based on integration. Let's see what the sum is. If the velocity of a particle is v, which is equal to at plus bt square, right? So they have given us the velocity where capital A and capital B are the constants. So A and B are constants. That's what they have given. Then the distance traveled by it between 1 second to 2 seconds is. So what I'm supposed to find is I'll have to find the distance, right? First, let's put the differential formula for velocity. It will be like v, which is equal to dx divided by dt, right? So here what I'm supposed to find is the distance or the displacement, right? So both are just the same thing. So you should be clear. So here I'll have to find the distance or displacement. If I have to get the distance, what I should do, I'll have to do the cross multiplication, velocity times the dt, right? So this will give me that particular small distance that I have covered. If I have to get the entire distance between 1 to 2 seconds, what I should do, I'll have to do the integration, right? So here I'll do the integration to get the dx displacement, right? So this is something that we have seen in the second part of the theory, right? Area under the graph, right? But in the velocity time graph, area under the graph will give me the displacement, right? So same thing here. So here I'll have to find the displacement, so I'll have to do the integration. So area under the graph is nothing but the integration, right? So the same thing, but here instead of giving us the graph, they have given us the equation, right? So I'll do the integration of this equation straight away. No doubt should be there. So the velocity v, so you'll have like displacement dx or x, which is equal to integral of v dt, right? So instead of v, I'll be able to substitute this one straight away. So when I do substitute it, you'll have integral of at plus bt square dt. Okay, now they have given us the limits, right? So they have given us the limit between 0 to, I mean like 1 to 2 seconds, right? So I'll have to substitute the limit over here. So it will be like 1 to 2. So if I do without those limits, I'll get like answer like indefinite integral, which means those limits are not specified. So with that formula, if I just substitute the limit, I'll get the answer straight away for that interval between like 0 to 2 seconds, something like that. In this situation, they have given us clearly between like 1 to 2 seconds. Okay, so if I do it without those limits, I'll get the answer for 0 to n seconds. Okay, if I substitute 2, then I'll get the answer to be the answer for like 2 seconds. If I substitute 4, I'll get the answer for 4 seconds. But in this situation, they have clearly mentioned as the interval should be between 1 to 2 seconds. Okay, so that's why I have substituted the limit straight away. Okay, so now let us do the integration. When I do the integration, you'll have, so this is a pattern. Okay, so this is actually a pattern. So when you do the integration, you will represent it with square bracket. Before integration, you will represent that one with an elongated s. Okay, so if I represent it with square bracket, it actually means the integration is done. Fine. So after integrating this one, you'll have at dt. If I do the integration, you'll have at square by 2, right? Because capital A is constant, therefore that will be left. T is the variable. It should be like t power n plus 1 divided by n plus 1. So t power n plus 1 will be t square divided by n plus 1. That's going to be 2 plus 1. I mean, that's going to be 2, right? 1 plus 1 is like 2. Fine. So the next one is plus bt cube. It should be like 3 divided by 3. Now I can apply the limits 1 to 2. Fine. So if I don't apply this limit, it actually means if I substitute only 2 into this equation, it should be like the distance, I mean, the distance covered for 2 seconds will be my answer, right? If I just substitute 3 into this equation, then the distance covered in the 3 will be my answer. Okay, but here they have specified as it's between like 1 to 2. Therefore, first I will find out what's the distance covered in 2 seconds, then I'll subtract it with the distance covered in 1 seconds. Therefore, I'll get the leftover part. Okay, it should be clear, right? So first I'll substitute the upper limit and then I'll subtract it with the lower limit, right? So when I substitute the upper limit, I'll have a by, I mean 4a by 2. Okay. So instead of t, I'll substitute 2. Therefore, that's going to be 4. 2 square, which is like 4a divided by 2. And the next part will be like plus, you'll have bt cube, right? So you'll have 8b divided by 3. Okay. Now the upper limit is substituted. Now I will have to subtract it with the lower limit. Okay. So negative of, let's multiply the negative straight away into the bracket. So I'll have minus a by 2. Okay. Negative of b by 3. Okay. Now let's do the solving. So if the denominator is same, I'll be able to solve it straight away. So you'll have like 4a by 2 minus a by 2, which will give me 3a by 2, right? So the first part is done. It's like 3a by 2. Then for the second part, it's like 8b by 3 minus b by 3. That's going to be 7b by 3 plus 7b by 3. Now the second one is also done, right? So let's match it with the options that we have. 3a by 2 plus 7b by 3. Yeah, the answer here is like option 1. 1 is going to be my answer, right? You shouldn't have doubt in this question. So these are like simple questions, fine. Just do the integration to get the displacement. In the situation, they have given you the equation. Therefore, we wouldn't be able to find the area under the graph. Straight away, do the integration. And then if they have given you the limits, just substitute upper limit minus lower limit. You'll get the answer, right? Next sum is the position x of a particle of mass m moving in one dimension under the action of force. Okay, so they are given the position in terms of x, okay, as usual, and then they have also given you the extra term which is like mass m. So you are having an one dimensional motion because of a force is related to time t by an equation t equals root x plus 3. Okay, so they have given us the equation in terms of t, fine. What they're asking us to find is the position of the particle when the velocity becomes 0, right? So what I'm supposed to find here is the position x of the particle when the velocity becomes 0, right? So they have given you the points. So what I need to find is like velocity, right? So velocity v will be equal to displacement by time. Okay, so v will be equal to change in displacement or else dx divided by dt, right? So in the question they have given us the relation for the x straight away, right? So here I'll have to substitute x in terms of t, right? So first I'll do the rearrangement thing, then I'll be able to substitute it. Okay, so if I do the rearrangement, you'll have x which is equal to t minus 3 the whole square, right? So instead of x, I'll be able to substitute t minus 3 the whole square. Just have done the rearrangement. So you will have something like this, d divided by dt of t minus 3 the whole square. Got it? If I do the differentiation, you'll have n x power n minus 1. So whenever you get a term, what and 2 or 3 terms, how you should do is, first you'll have to do the differentiation considering this complete term to be a single variable, which means single t. Okay, so if I do the differentiation, you will have, as usual, this is the same thing, the numerator, I mean the power comes to the coefficient, and then you'll have like 2t minus 3, and the power will decrease by a value of 1. So you'll have like 2t power minus 3 the whole power 1. Okay, so let's leave it. Then what you should do is you'll have to differentiate this term one more and then multiply it to it. Okay, so first I'll consider this entire term to be a single term, and then I'll do the differentiation. And then what you will have to do is you'll have to consider this term once again and then differentiate it and then multiply by it. Okay, if it was like t square, then that's not a problem, 2t will be the answer, but here I'll use something called chain rule. Okay, so that's not needed. Generally what you should know is if there is multiple terms into a bracket, then you'll have to do the differentiation considering that complete term to be a single term. Okay, then after doing the differentiation, just differentiate the term which is inside the bracket one more time. Okay, and then multiply it. So if I differentiate this one once again, I'll have like t. If I differentiate this one, that will be like 1. Okay, got it, 1. And then minus 3 is like constant, therefore that 2 will become 0, right? So you'll have just 1 in this situation. If it was something t square or something like that, then you'll have like 2t multiplied to it once again. Okay, so these are some max basic things which you should know. So as if now you should be able to understand this one, right? So chain rule is something that you need to know, right? When you have an complex term inside a bracket, then you consider that entire term to be like single term, do the differentiation, then consider that term and then do differentiation one more time and just multiply it, right? Okay, so that's how I got this answer. Anyway, the point here is I just found the velocity b, fine. So what I'm supposed to find here is what will be the position x when velocity will be like equal to 0, right? So if I put 0 here, I'll get the time t. Then if I substitute that time here, I'll get the x, okay? So first let us find the time t. So what I'm about to do here is I'll just put 0 for the velocity. Then it will be like 2t minus 3, right? So 2, it goes to the denominator, the term becomes 0. So time will obviously be equal to 3 seconds. Okay, now I have got the time. Let me substitute this time in this equation and I'll get the x here. So if I substitute t in this equation, it's going to be like 3 minus 3, which is like 0. Therefore, x position will be like 0. Got it? So here the answer is option 2, right? You should be clear with this sum. Here I have found the position x, okay? When time t was equal to 3 seconds, the position of that object was like 0, okay? That's what I have found here. If they have asked us to find the displacement, what I should do is, this is just the position. The displacement actually means final point minus the initial point, right? So here what I'm supposed to find is the position, therefore I just substituted it straight away. If it was like displacement, this is the final position, right? I'll have to find the initial position by substituting 0 in the parent equation. So if I substitute here 0, I'll get the initial position, right? When time t equals 0, that will be my initial position, and then when time t equals 3 seconds, that will be like final position. And if I do the subtraction, final position minus initial position, I'll get the displacement, okay? So in this sum, they have just asked us to find the position, the final position of the particle. Therefore, I was able to do it straight away, okay? There is no point in finding displacement, which means final position minus initial position, right? You should be clear with this sum. Let's move on to the next one. Next sum is actually graph-based sum. Let's see what it is. A particle shows the distance time curve as shown in the figure, okay? So there is like distance time curve, that's what they have given in the figure. The maximum instantaneous velocity of the particle is, so when will the particle have maximum velocity? So along the y-axis they have given us the displacement, and along the x-axis they have given us the time, okay? What I'm supposed to find is the maximum instantaneous velocity, right? So velocity v is nothing but dx divided by dt, right? So we know that if the velocity v has to be maximum, then obviously dx by dt should be maximum, right? So if the slope is like more steeper, then the velocity will be maximum, right? If the slope is like shallow, which means close to x-axis, in that situation the velocity will be minimum, right? So I'll have to find a point. Obviously the differentiation of this graph will give me the slope of that entire curve, right? So I'll have to get a slope which is nothing but the velocity in this situation. Therefore, if I get the slope should be such that steeper, which means closer to y-axis. That will be like more velocity, right? So as that becomes shallow, which means as it goes towards the x-axis, then it just reaches 0. So velocity is steep, which means it has more value into it. Then as it approaches 0, which means it becomes shallow, the velocity goes to 0. Then obviously the direction might change, right? These things are something that we have seen in the theory section, the second theory section. So you should be clear with, while doing the graph, we just saw all those logics into it, right? So here what I'm supposed to find is at which point the velocity is steeper. That's what I'm supposed to find here, okay? So at point A, it seems to be like 0, right? So this is where the distance is starting. Therefore, the velocity could be like 0 or a little bit extra. It depends, okay? Anyway, this is shallow, which means closer to y-axis. Then if I consider the point B, that is a little bit steeper when compared to point A, obviously. Then if I consider the point C, that is much more steeper when compared to point B, okay. Then if I consider the point D, so the confusing part here is like C and D. But if you consider like D, it seems to be like at that point, so it just increases, then it starts decreasing, right? So here obviously it just increased, and then there came a point where it became much steeper, and then at point D it became a little bit shallow because it is about to reach like at some point the velocity is again going to reach 0, right? So here what I'm doing is I'm just comparing the slope at every instant, okay, because the slope at that particular point represents the velocity. Therefore I just picked 4 points in this situation. It's like A, B, C. That's what they have given in the graph. And then for that every particular point, I just drew a line, okay. So when I drew a line, it became pretty clear that the point C has more steep when compared to rest all other points, right? Because the only confusing part here is like C and D, but when you consider D, it seems to be like, again, it seems to be like going to 0, right? Therefore, that should be a little bit shallow when compared to the point C. Therefore, the answer here should be like point C, right? More the steeper, more the velocity. Therefore, the answer should be like point C. So the thing that matches with C is like option 4. So 4 is my answer, right? These are like graphical logic based sum. You shouldn't have confusion in this one. It should be clear. Let's move on to the next one. Next sum is similar to that of the previous sum that we have seen. Let's see what it is. The position x of a particle with respect to time t along x-axis is given by x, which is equal to 9t square minus t cube, right? So they have given us an equation with respect to x, fine, where x is in meters and t is in seconds. So they have given us meters and seconds, fine. What I'm supposed to find is what will be the position of this particle when it achieves maximum speed along plus x direction, right? So I need to find the position of the particle, which means I'll have to find that x of that particle when it achieves maximum speed, right? If I have to get the maximum or minimum, the last math logic that we have seen while doing the theory part, right? So the logic was to, to differentiate that equation, and then I'll have to equate it to 0, which means I'll have to equate the differentiated velocity to 0, okay? So when I differentiate it and equate it to 0, the slope will become equal to 0, and that point could either be maximum or minimum, right? So the question, in the question itself, they have given us straight away it's like maximum, therefore it should be like maximum, right? So first let me get an equation for velocity, right? Then I'll differentiate it once again and equate it to 0. Okay, so I'll get that point. Okay, that point should be like the maximum speed point. Okay, so let's do the math and I'll get the answer straight away. Fine, so let's do it. So first I'll find velocity v. Velocity v is nothing but dx divided by dt, right? So x is something that they've given in the question itself. X equals 90 square minus t cube, right? Therefore velocity v will be equal to 18t minus 3t square, right? Now I have got the velocity v. What I'm supposed to find is what will be the position of that particle when this v reaches maximum speed, right? So in order to substitute the time, I just need to know what time should I substitute, right? To substitute the time, the hint that they've given us, the speed will be like maximum. That's the hint that they've given us here, okay? So to get the maximum speed, what I should do, I'll have to differentiate this equation, whatever it is, maximum speed or maximum distance, depending on the question. Here they have given us the maximum speed, which means I'll have to get a equation with respect to velocity, then I'll have to differentiate this equation and I'll equate it to 0 to get the maximum or minimum point, right? So once again I'll differentiate this one. So I'll have like b dash, which is equal to 18 minus 60, right? So now I have got the b dash. I'll equate this one to 0. Okay, when I equate this one to 0, you will have time to be like minus 18, so that's like 60, which is equal to 18. So t will be like equal to 3 seconds. Okay, now I have got the time. Fine, now I can substitute this time into the above equation to get the velocity, right? The question that they have asked here is not to find the velocity, it's to find the position, right? So I shouldn't substitute this one into the velocity equation. I should actually substitute this time into this displacement equation or the position equation. Okay, so if I substitute this one into this position equation, I'll get the position of that particular point, right? So that's what I'll have to find, right? If they've asked us to find the displacement, then it will be like final position minus initial position. So the final position will be like some point that I'm about to get. The initial position will obviously be 0, right? If I substitute 0, 0, the initial position will be like 0. So final minus initial will be same as that of the position, right? So in this situation, the initial position was 0. Therefore, the position and displacement both were just the same thing, okay? You should be clear. Therefore, to get the position or displacement in this situation, both are just the same thing. I'll be able to substitute 3 in the equation that they've given in the question, which will be like 9 into 3 square, which is like 9, okay, minus, so we have the next term is like 29, right? 3 3 9 3 is 20, so 9 into 3, let's make it this way, okay? So the answer will be like, if you factor out 9, you'll have 9 minus 3, right? So 9 minus 3 will be like 6, okay? So 6 into 9 will be the answer. So the answer is like 54 meter. The answer here is option 1. Okay, you should be clear with this sum. So the thing is, it's just the same way that we have done the previous sum. I just found the velocity v. In this situation, they have asked us to find the position. Okay, so in order to get the position, I need to know the time. So to get the time, the hint that they've given over here is the maximum speed, right? To get the maximum speed, I just equated it to 0. So you do once again differentiation, the answer will obviously be negative, okay? So if it is like negative, obviously this is going to be like maximum. You do it by yourself from the theory that we have seen. So anyway, in the question itself, they have clearly mentioned as this is going to be maximum, right? So now I have find the time for the maximum speed, right? They asked us not to find the speed, instead they asked us to find the position. So I'll substitute that 3 seconds in the parent equation which is in the question. Okay, when I substitute that one, I'll get the position. Got it? So that will be my answer. Even if they asked you to find the displacement, it's the final position minus initial position. In this question, initial position was actually 0, right? Therefore, when you do the final minus initial, you will end up getting the same answer in this question, okay? There shouldn't be any doubt in this question. Let's move to the next one. Next question is, a particle moves along a straight line OX, okay? So this is a straight line motion. At a time t, the distance x of the particle from O is given by x equals some equation. So they have given us the equation for the position, which is like x equals some number. Fine. How long would the particle travel before coming to rest? Okay. So what I'm supposed to find is the distance traveled before coming to rest. Fine. So before coming to rest actually means velocity should be equal to 0, right? So when velocity was equal to 0, how far the distance it has covered, right? So how long would the particle travel? So what they're actually asking us to find is the displacement in the situation. So here I'll have to find the initial position and the final position, and the initial position will be like when time t equals 0, I'll get the initial position which will be like 40. From the final position, I'll have to subtract the initial position. Then I'll get the how long the particle has traveled, which means I'll get the displacement out of it, right? So here they have given us the equation for the position, right? So we'll do the math and we'll get the answer straight away. So here, if I solve this sum, which means the hint that they're given is when will the velocity become 0? That's what I need to find. So in order to get the velocity, I'll have to differentiate the equation that is in the question, right? So I'll have v which is equal to, if I do the differentiation, I'll have like 12 minus 3t square. Okay, so I should find the time when the velocity will be equal to 0. That's the time that I need to find here. Therefore, if velocity was equal to 0, then you will have something like this, 12 which is equal to 3t square, right? So if I do the cancelling, I'll have like 4 in the situation. So if I take the root for 4, I'll get 2, right? Therefore, time here is like 2 seconds. Now I have got the time. So now I'm ready to substitute this time in the equation in the question, right? So in order to get the final position, let's make it this way. Final position will be like xf, okay? Subscript f, okay? So if I substitute 2 there, we'll have like 40 plus 12 into 2 will be like 24 minus 8, okay? So now let's solve this one. So if I subtract this one, you'll have like 16. So the answer will be like 56. So the final position is like 56 meters. Okay, so this too is in the question. So 56 is not the answer here because what they're asking us to find is how long would the particle travel before coming to rest. Okay, so what is the initial position? That's what I need to know. From the initial position will be like when time t equals 0, because time negative is not possible, right? Therefore, when time t equals 0, I'll get the initial position. I'll have to subtract final position minus the initial position. In the previous sums, the initial position was equal to 0. Therefore, there is no problem into it. Anyway, they were asking us to find the position in those sums. But in this sum, they are asking us to find the distance or displacement. Therefore, the final position minus initial position will give me the distance that has traveled, right? So here, the final position was like 56 meters. Then the initial position would be 40 meters. Obviously, when I substitute 0 here, these two terms become 0. And 40 will be the initial position in the situation. Therefore, the initial position xi will be equal to 40 meters. When I subtract these two things, I'll get the distance traveled, which will be like del x. That's going to be del x, which will be like 16 in the situation. 16 meter is my answer. Therefore, the answer here is like option 1, right? So these are some pattern sums that we are seeing continuously. You should be clear with this type of pattern sums, okay? You shouldn't have any doubts in this sum. Let's move to the next one, which will be the last sum for this session. 10th sum is the displacement x of a particle varies with time t, okay? So they have given us the equation for the displacement, which is like x equals a e power minus alpha t plus b e power beta t, okay? Where a, b and alpha and b are positive constants, okay? So they have given us a relation for the displacement x. Got it? So they have given us the relation. What I'm supposed to find is the velocity of a particle will be. So what I need to find is the velocity of the particle. That's what I need to find. Therefore, they have given us the equation for x. So the velocity of the particle will be, so v is something that I need to find, and then I'll have to relate it with the options that they've given over here, okay? So if I do the differentiation of the equation that they've given over there, I'll get the velocity, right? So first let me write the position equation, which is like a e power minus alpha t plus b e power beta t, right? So now if I do the differentiation, I'll get the velocity. Therefore, velocity will be equal to dx by dt, right? So this is something that we have seen in the theory part, okay? I told you should remember this formula, right? We didn't see the proof, but I gave you the formula, right? So if you have something like e power ax or something like that, then that a constant in the power should come to the coefficient, okay? So here it will be like minus a alpha e power minus alpha t. That's what you get, right? Okay. And then for the second, you'll have something like this plus b beta e power beta t. So this is what you are supposed to get. So let me rearrange this equation in a convenient way so that I'll be able to explain the options clearly. So if I rearrange it something like this, minus a alpha divided by e power alpha t, and then plus, I can write the next term straight away. You'll have b beta e power beta t, okay? So now let's consider this equation with the options that they've given over there, okay? So what they're asking us to find is the velocity of the particle will. So how does it actually be related to this equation? Be independent of beta. This doesn't make sense because velocity depends on the beta, right? Independent of beta doesn't make sense. Therefore, first option is wrong, okay? So the second one is drop to 0 when alpha equals beta. If alpha and beta are same, so these two things will get cancelled out. That's what they are given. So that doesn't make sense, right? These two things will obviously not get cancelled out. So option 2 is also wrong. Goes on decreasing with time or goes on increasing with time. So from these two things, I'll have to get one option to be right? So let's consider with respect to time. Okay. Here, let me consider the time to increase. Fine. So goes on increasing. Let me increase the time. If I am about to increase the time in this situation, and then here also the time will also get increased, right? So if the term t increases, what will happen? Let's see what happens to this entire velocity term. Okay, so if time t is about to increase, what will happen to this negative term? Because the first term is negative, right? Minus a alpha, this term is negative, this term is positive, right? So here as t increases, the denominator will increase, right? So as the t increases, the denominator will obviously increase. If the denominator increases, then this complete term will decrease, right? So what happens here is this complete term is about to decrease. So what will happen to the other term? These entire terms are in the numerator, therefore this term will keep on increasing. Fine. So as t progressively increases, this entire term is going to increase because the negative value will start to decrease and then the positive value will start increasing, okay? So when you consider those two things, as time keep on increasing, what will happen? The negative value started diminishing, whereas in the case of positive value, it started increasing, okay? So if you do the addition, obviously the velocity has to be greater, right? So as time increases, this complete entire term has to increase, which means velocity will have to increase. Therefore, the answer should be like goes on increasing with time. Okay, therefore the answer here is option 4, right? So you should be clear with all those sums that we have seen. Okay, so we have seen sums that is related to velocity, displacement, okay, and then average velocity, and then from the concept of velocity and then the speed we saw some sums, okay. Then from differentiating the equation we did find out velocity and all those things, okay. So these were the sums that we have seen in this session. So we did around like 10 sums in this session, right? So as I've already mentioned, we need around 3 sessions to complete this PYQ part, okay. In the first session we have completed 10 sums. In the next session we'll complete around like 10 to 11 sums, okay. So with this the video gets completed. Bye.